Okay, so this is section 4.8, number 39. So it says a plane is observed approaching your home and you assume that its speed is 550 miles per hour. If the angle of elevation of the plane is 16 degrees at one time and 57 degrees 1 minute later, approximate the altitude of the plane. Okay, so let's draw a picture that kind of represents that and then look at what trig ratio we can use. So this is 4.8, number 39. I'm going to zoom out. A little bit. Okay, so let's say my home is here and it says there's a plane that's kind of flying over, right? And so at one point the angle of elevation, so here's the base there, so the angle of elevation from my home to the plane at one point is 16 degrees. And then as the plane kind of gets closer, because it's approaching my home, it's getting closer to my home. As it gets closer, the angle of elevation kind of rises up a little bit, and now it's 57 degrees. Okay, so I'm going to say this is 16 degrees. This entire piece here would be 57 degrees. Okay, and so the question is just approximate the height. So the plane hasn't dropped in altitude at all, so I'm just going to call this H. And if I were to drop this down, this would be H as well. All right, so H is the same. It's just kind of going forward closer to my home. Okay, so what we have is two triangles that we'll try to use to figure out what H is. So I'm going to draw the triangles separately. So if I look at the 16-degree triangle here, I have my base, I have my home. Here's the 16 degrees, and here's H. Oops. And then I also have the 57 degrees, so it's kind of like a shorter triangle, but here's 57 degrees. The height is still the same here. And here's still my home. Okay, so what we do know is that the plane is traveling, or we assume it's traveling 550 miles per hour. So that means in a minute, it's gone some distance that we can kind of figure out. Because honestly, this entire distance here, go from here to here, is different from the distance from here just by a minute, however far the plane can travel in a minute. So if I look at the distance of my little 57-degree triangle, I'll call that X. The 16-degree triangle, this distance is going to be X plus whatever that extra piece is, however far the plane can travel in a minute. So I'm going to just do a little conversion. We have 550 miles per hour, and I'm going to multiply that by 1 hour per 60 minutes. We want to figure out how fast, or how far I should say, it can go in just a minute. So cancel out my hours. I take 550 and divide it by 60, and I get 9.17. Say approximately. So it can go 9.17 miles in a minute. Okay, which means the distance between these two, as it went from this point to this point, is just 9 miles. So I'll put here plus 9.17. All right, so now I have enough to at least use a trig ratio and then try to somehow figure out what H is. So just looking at this triangle, I have my right triangle. I know the opposite side here is called H. I know the adjacent side has another expression. I know nothing about the hypotenuse. So whenever that happens, when I know information about the legs and I'm not involving the hypotenuse at all, I have to use tangent. So I'm going to say tangent of 16 degrees. There we go. Equals the opposite side, which is H, over the adjacent side, which is X plus 9.17 miles. Okay, it's not good that we have two variables, two unknowns, but we'll try to fix that. Here, the same thing. I have across from the 57, I have the opposite side as H. I have the adjacent side as X. I'm going to say tangent of 57 degrees equals my opposite side over my adjacent side. Now we're trying to figure out what h is, but we can't do that when we have two unknowns, right? We have x and h that we don't know. So there's probably different ways we can kind of figure this out, but I'm just going to isolate h and then solve and see what we can do. Do a little bit of algebra to solve and see what we can do. So if I multiply, kind of cross multiply here, I get that x plus 9.17, it's supposed to be a 17, times tan of 16 degrees equals h. And if I do the same thing here and multiply both sides by x, I get x times tan of 57 degrees equals h. So now I have kind of a system of equations. I have one expression for h, I have a second expression for h. I can put them together, and that way it will at least eliminate one of my variables, and I can start solving. So I'm going to say if this equals h and this guy equals h, that means they're both equivalent. So x plus 9.17 times tan 16 degrees is equal to x times tan of 57 degrees. Now I've eliminated h, which is kind of what I'm trying to solve for, but if I figure out what x is, I can just go back and plug in and I'll be able to find h. So I'm just going to plug this into calculator, tan of 16 degrees. And I get, so I'll put here x plus 9.17. I get 0.2867, right, for my tangent. And then I'll do the same thing on this side. X times tangent of 57, which is 1.540. And now I'm just doing a little bit of algebra to solve. So I'm going to distribute, get 0.2867x plus whatever 9.17 times this is, which happens to be 2.628. And then here I'll just put 1.54x. And I don't need that extra zero there. And then I'll move all my x's to one side, keep my numbers or my constant here. So it's 2.628 equals, if I subtract by 0.2867 on both sides, I end up with 1.2532x. Right, so it's kind of like I subtracted here so that it goes away, and I also had to subtract it on the right side. Okay, and then I can divide both sides by this 1.25, and I end up with 2.10 equals x. So x is 2 miles, we'll say 2.10 miles. I want to know what h is, so I have two formulas here for h. I can plug in this formula, I can plug into this one. This one looks easier, so I'm going to use that. And it says that h equals x times tan of 57 degrees. So then I can say, well, 2.10, because that's what my x is, times tan of 57 is h. And if I plug that in the calculator, I get 3.229. We can round that to 3.23 or 3.3 miles. So the plane is 3 miles high in the air. Okay.